Okay, and welcome back. So, last time we set up the objective function for the monetary authority, and as I explained that objective function, how it would possibly relate with the public or the Phillips curve for output, it led to the question of how much inflation is a central bank willing to accept if it means a slight increase in output, because changes in inflation, well, an increase in inflation will reduce the monetary authority's utility. So they want to stabilize inflation. They want to keep it as low as humanly possible, but at the same time, they still want it to be kind of high ish, or at least just high enough to increase output above its natural rate. Because if that happens, then their utility may possibly increase more. So now that we have asked that question, and now that we have set up what the players are in the game, what their incentive structures are in the game, let's go ahead and solve the game out. So what we have is this problem where the central bank needs to figure out how much they're going to inflate. Well, if we're facing trade-offs, right? We're trying to figure out what the best possible policy is going to be. It kind of sounds like we're going to be doing some utility maximization, doesn't it? Well, if that's what you think is going to be happening, then you're correct. There's going to be some utility maximization going on. So, how do we maximize the utility here? Well, let's first get our handy dandy paint marker and erase this and just rewrite it in pink. Why? Because who doesn't like pink? And it will also make it a little bit easier to see when we start plugging some things into each other. Now, I will say this. This is the last time you'll see calculus in this course. This is the only time that you'll be required to do any calculus on an exam. The exam that you will be seeing as the time this video has been posted and emailed to you, or I guess really the practice exam you'll be seeing as well as the exam that you'll be getting, will not require you to do any calculus. You should be able to figure everything out on the exam without having to do a single derivative. Now, if we're going to be looking at this, right, the monetary authority is going to be the one that maximizes utility. How do we know that? Well, the monetary authority is the only thing here with a utility function. So they're going to maximize their utility, and then the question becomes with respect to what, right? What variable can they choose to maximize utility with respect to? Well, they can't directly affect output in this model, right? They can't just go, hey, we want output to be this by dictate, and that's just that. That's not how this works. Instead, what they do is they affect inflation in hopes of affecting output, right? So they'll set inflation in hopes that the inflation policies they put forth will be driving output above its natural rate. So that means, well, there's basically a utility function here, and there's a constraint. What's the constraint? Well, the constraint is the public's function. It is the Phillips curve for output, right? So they can set inflation to whatever they want so long as it doesn't mess with this constraint too much, as long as that constraint becomes satisfied, so to speak. So what do we do in order to do that? Well, what we can do is we can actually take the Phillips curve for output and plug it into the monetary authority's utility function. How would we do that? Well, let's take a look. What is the Phillips curve? What's the left-hand side variable on the Phillips curve? I'd venture a guess by looking at it and remembering my left and right that it's probably yt. So then it becomes a question of, is yt anywhere in the monetary authority's utility function? Answer to that would be yes. It would be right here. So how about I erase this? Make that pink as well. So now we can see exactly where we're supposed to plug stuff in. Just take the pink, plug it in for the pink. So what is that going to look like? Well, all I do is if yt in equation 1 here is equal to this stuff, then I can take this stuff and plug it in for yt in equation 2. So let's go ahead and do that. Let's go ahead and make some stuff happen. So I take this and I plug it in for yt here, which gives me yn, the natural rate of output, minus alpha, right, really the slope of the Phillips curve with respect to deviations in inflation from its expected rate of inflation, like that. And then, well, it was minus yn, minus the natural rate, because we're curious about how output deviates relative to the natural rate. And then we just subtract 1/2 pi t squared. And this is what is being maximized. Now, we can simplify this a little bit further. Because if you look inside the parentheses that lambda is being multiplied by, we look at that, there's a plus yn and a minus yn in there. So what we can do is we can actually just cancel out those yns and instead have a somewhat shorter utility function that we want to play with. And my mistake, that was not a minus alpha, that was a plus alpha. Fortunately, we didn't get far enough in for that to really become much of an issue, thank God. So that just gives us this. Lambda times alpha times pi t minus expected pi t, right? So actual inflation minus the expectation of inflation, plus that epsilon t, that zero mean serially uncorrelated source of shocks, minus 1/2 times inflation squared. So this is the central bank's utility function. This is the utility function the central bank is going to be maximizing with respect to inflation. So they can choose inflation, they can't choose output. So if they're going to do that, I don't know why I just stopped for a second there. My brain just like kind of died out or something. We'll call it a senior moment. I'm 33 now, so getting on in my years. It's about time to retire already. Fresh out of school, about to retire. I'm old. I'm an old man. Anyways, they can control inflation, they can't control output. How do we know that? Well, actually, just looking at their utility function tells me they can't control output. There's nothing for output in there anymore, right? There's what output is equal to, sort of, in there, right? The stuff that drives output above the natural rate, but it's all done through inflation. It's not done through actual changing of output itself. They cannot directly change output because there's no output in this equation. So they maximize their utility, but there's a little bit more to it than just that. What is it? Well, give me a second. So, what do we get? Well, what we first need to say is that the monetary authority is maximizing their expected utility with respect to inflation. So you've seen utility maximization already, but there's also expected utility. Why is it expected utility? Well, it's expected utility because there are shocks in the system. So it's not going to be a deterministic system. There's going to be a little bit of stochastic stuff going on here. Nothing that you actually really particularly need to be worried about, because as we'll see in just a second, as they maximize their expected utility, a lot of things just kind of fade away and just go off to zero, and that's that. So I'm going to rewrite this thing in terms of an expectation. Now I can erase what's on the bottom. So this is the central bank's utility function that is being maximized. Well, now this actually gets quite a bit easier and nicer for us. How so? Well, what we get to do now is we just get to take a derivative, and we're taking a derivative with respect to inflation. So we're maximizing the agency or the monetary authority's utility with respect to inflation. What does that look like? Well, partial derivative time. We take the partial derivative of utility with respect to inflation, and then we set that equal to zero. Maximized utility. As we do that, I will take the expectation across this whole thing, which means the expectation remember I said it had a mean of 0. If you take the expectation of that shock, or really that source of shocks, the expectation of that's equal to 0. Therefore, this guy goes to 0. But as we take derivatives across the board with this whole thing, it wouldn't matter because it would kind of go to 0 anyways. So it like doubly goes to 0. Isn't that awesome? So as we do this, take my derivative all the way through. What does that give me? Well, I'm taking this with respect to inflation. Look everywhere that there's an inflation term that it's being multiplied by, and I differentiate with that. So this is pi t to the first power, right? So that's going to differentiate down to 1. So pi t to the first power, take its derivative, it goes down to 1. But it's going to leave those two coefficients of lambda and alpha. Okay, now what? What do I do now? Well, let's see. We're not doing it with respect to expected inflation, because that's not what the Federal Reserve is interested in trying to actually set. That's a little different. We'll see what role that plays coming up very shortly. So that expected inflation gets differentiated to 0, which only now leaves this 1/2 pi t squared. Well, okay. What's going on here? What's that derivative? Well, the derivative of 1/2 pi squared, take that 2, bring it down, multiply it, so this becomes 2 over 2 pi t to the power of 1. 2 over 2 just becomes 1, so I get minus pi. And I set that equal to 0. This is what you will see all the time with a model like this. You will get lambda alpha minus pi t equals 0. Well, I need to solve for pi t, right? I want to know what that optimal inflation rate is. Okay, well, this actually got really, really easy. All I have to do is just add pi t to both sides. And I get pi t equals lambda alpha. Now, why did I put a star over that? Well, I put a star over that pi t because this is the optimal rate of inflation. This is the rate of inflation that will maximize it, or that will maximize the monetary authority's expected utility function. If I were to plug that in there, that would be the highest level of utility the central bank could get. So let's hold on to this now, because it's now time to actually think about where the game theory comes in. Because we did the math, we figured out the optimal inflation rate, which is lambda times alpha, and now it's time to see what role this plays in managing, well, first setting expectations for inflation, managing inflation policy in hopes of trying to manage output by driving it above its natural rate to boost utility for the central bank. So since that is kind of its own fairly lengthy lecture, what I'm going to do is cut this lecture now. This is going to be the end of this one. Part, I guess, 4 will be coming, where we talk about the game theory, what happens, and it'll either be part 4 or part 5, where we talk about the different types of expectations within the game, whether we look at adaptive or rational expectations as well as trigger strategies. So that will wrap up this portion of the lecture. Thank you for watching, and we will be reconvening relatively shortly. Thanks. Bye.